Question 4. The current in an electric circuit in a mobile phone is 0.12 amps. The potential difference across the battery is 3.9 V. Calculate, so it's a calculate question, the resistance of the electronic circuit in a mobile phone, and also use the equation. Potential difference equals current times resistance. It's worth 3 marks. So 3 marks is a fairly normal amount. Okay, 2 or 3 marks is normal. So I'm not expecting any tricks here. Remember when we use every, so the first thing I do is rewrite the equation. If they've given you an equation like this, that's great. If you can't remember the symbols, and you think, well, I'm not sure about the symbols, make sure if you put the symbols next to the equation somewhere as a key, then what that will do is it shows the examiner, you know, okay, well, you're using V for that, I for that, R for that. Okay, and if you're right, that's great, but if you're not, now, if you use C for current, but you'd written it there, then usually that would get you the credit. Okay, so the first thing is we're going to rewrite the equation. So the E in every it stands for equation. So V equals I times R. The next thing is we're going to write our values. Now the way I like to do that is by giving myself a little bit extra space. So I put a line down there, so I've got this space to do my working in, and over here I can write my values. And I write down the values that I've got. And I forgot to underline these earlier. So current is that. Potential difference is that. The examiner will not give you numbers anymore unless they're useful. Okay. Be careful though of hidden numbers. And what I mean by that is I mean numbers like stationary. Okay, so stationary is 0. Body temperature, because body temperature is 37 degrees Celsius. You might get so water boiling, and that will be 100 degrees Celsius. Okay, so just be careful of words. Water freezing is 0 degrees Celsius. Just be careful of words that sort of hidden there. There's another one actually that so mains electric, so mains voltage is 230 volts always. So if they talk to you about mains electricity, you know it's always 230 volts. Now in this one they've just given us some straightforward numbers. There's no hidden numbers at all. So I've got I is equal to 0.12 amps, V is equal to 3.9 volts. The next thing I do is substitute, is enter my values. So I've got equation and values, and enter my values back into the equation. So 3.9 is equal to 0.12 times R. In terms of marks, I get a mark for that. Always make sure you enter your values before you rearrange. Now I need to rearrange to make R the subject. So R is equal to 3.9 divided by 0.12, and on my calculator, if I calculate that, it comes out to 32.5. So I get a mark for that. If I were to get this rearrangement wrong here, there's a chance I'd still get this mark here for the calculation. It's called error carried forward. The only reason there is a chance that would happen is because I've laid it out in this way. I've laid out all my workings. Now the only thing I haven't done is I haven't put the units on. Okay, the Y for units. Little note here, be really careful. Whatever you write on this line here always takes priority. So if I were to be in a bit of a rush and I wrote that down, 325 rather than 32.5, even though I've done all of this right, it would be marked incorrect. This bit here would be marked incorrect. I'd only get 2 marks out of 3. So whatever you write on this line here, be really careful that it is what you want, what you mean it to be, because this line here takes priority. Okay, the examiner has to read that one first. Right, part B. Fully charged battery discharged when the mobile phone was used. Average power is that. Time taken to fully discharge is that. Calculate, okay, the energy transferred by the battery and use that equation. Power equals energy divided by time. It's worth 4 marks. So that's a lot. So that's more than I'd probably expect for a calculation question. It's 4 marks. I'm going to keep an eye out here, make sure there's nothing sneaky going on. Well, I've got power is equal to energy divided by time. power there, 0.46 watts. I've got time here, it's 2,500 minutes. Okay, so let me write my equation. So I've got power equals energy divided by time. My values over here, I've got power is equal to 0.46 watts. I don't need to convert that. When I'm converting, I'm always looking out for, so look out for things like milli, centi, minutes, hours. Okay, all those things there are not normal amounts that we would use. Kilo sometimes. The only time we'd ever use kilo is when we're using kilograms. Mega, capital M, as well. For, yeah, again, they're not our normal units. So T is equal to 2,500 minutes, and that minutes there, that's the catch, isn't it? So I need to convert that to seconds. So that's 2,500 times 60. If I check in my calculator, that is 150,000 seconds, and that is worth 1 mark. Even if you decide not to use it in the calculation, it's worth 1 mark there. Okay, now I'm going to enter my values. So 0.46 is equal to E divided by 150,000. Make E the subject. So E is 0.46 times 150,000 equals 69,000 joules. Okay.